I want to ask you something. If you're a computer science student or someone just trying to get into software engineering right now, what's the one question that keeps coming up in your head? I'll tell you what it is. Is AI gonna take my job before I even get one? And this question is everywhere, in university group chat, in Reddit, in threads, in the comments of every tech videos out there. And honestly, I get it, man. You spend so many months learning how to code, maybe years, and now you're watching AI do all code generation in seconds and thinking, what's the point? But here's the thing, that question, whether AI will replace software developer, that's actually the wrong question. The students who keep asking that question will spend the next 2 years anxious and confused, but the ones who ask the right questions will keep moving forward with clarity. So what's the right question? What kind of software engineers becomes more valuable when AI can already write all the code? That's what we're going to figure out today. But let me just take you back a few years. The path to software development was actually it's almost predictable. You learn to code, you build a few projects, learn React, for example, put them on GitHub, you apply for junior roles. That was the formula. And it worked so well because back then the barrier was just learning how to write code. If you could write a function, loop through data, connect an API, build a working form, you had something really valuable that you could offer to companies. Honestly, and most students today are still following that same path. They're grinding on lead code, they're finishing their Udemy tutorial courses, they're collecting certificates, waiting for the moment that they think they know enough to get hired. But that path is gone now. Here's what's actually happening. AI tools today like Copilot, Cursor, ChatGPT, Codex, Claude, they can write front-end components, back-end routes, SQL queries, they can generate unit tests, write documentation, and build a basic working prototype. A person with no coding experience can just write a prompt or just paste the prompt and get something that looks beautiful, like real software, in like 10 to 15 minutes. Now, I want to be clear. I'm not saying this to make you panic. I'm saying this, it's true and it's happening already. I've tried it and you deserve to know it. The beginner layer of software work, the stuff that used to take a junior developer a few hours, that layer is gone. That layer is now replaced by something much faster, which is AI. So if your plan was to compete purely on knowing how to write this code, whether you can write code very fast, that plan needs to change. But here's what I want you to hold on to. Knowing how to write code was never actually the hard part. If you were a junior developer and you were hanging on your ability to just write basic code, you're never gonna go far to begin with. The hard part was something different. That's where the real opportunity is sitting right now. Here's just what we're gonna cover today. What AI can do, where the value in software engineering is moving to, the mistake a lot of students are already making today, and what you should actually be building for yourself right now. Let's go. I want to be honest with you on this here because I think a lot of people, especially the ones in education, are still kind of dancing around this. AI is genuinely good at certain things. Give it a clear prompt and it will write you a working login form, a REST API route, a function that filters or sorts data. It will explain an error message to you, suggest a fix, write documentation, generate test cases. For tasks that are simple or just very well defined, AI is often fast and accurate enough. And this is why so many juniors or students feel the pressure. If you spend 6 months getting comfortable with basic code and a tool can produce this in a matter of minutes, you start asking, what am I actually doing? And that's a fair question. And the answer is not nothing. The answer is that you need to bring something AI cannot bring. And to understand what this is, you need to understand where AI actually breaks. Here's the thing that changed how I think about this. The hard part of software engineering was never sitting down and writing the code. It was figuring out what the code should do. What problem are we solving? What should happen when a user does something that we didn't expect them to do, which happens more often? What should happen when the server goes down? What's the correct output we're expecting? What does the user actually need? Not just what they say they want. These are not coding questions, they are thinking questions. AI should not be thinking for you. If the problem is unclear in your head and you go to AI for the answer, what you get back is a confident sounding code that solves for the wrong thing. I've seen this happen all the time. Someone gets AI to build a feature, it looks amazing, it runs, they ship it, and then 3 days later, someone says, this isn't what we needed at all. And now everything has to be reworked. The code is not the problem. The thinking before the code was the problem. Someone still has to understand the problem deep. Someone still has to decide what the right solution looks like. Someone still has to say, yes, this is correct, or no, go back and fix that. And that someone is a software engineer. AI doesn't replace that role, it just makes the typing part a lot faster, if that makes sense. It's kind of like saying the core skill of an author is typing the words into his book. No, it's what goes into the book. Does that make sense? Let me tell you about a pattern that I keep seeing. Students are using AI to generate code that they do not fully understand. They paste the output, it runs, the screen looks right, they move on. And on the surface, it looks like they're building. It looks like there's progress. But ask them to explain what the code actually does. Ask them to change one small part of it. Ask them what happens if a user does something unexpected. Ask them why a certain decision was made. Silence. They borrowed the code, they didn't build the understanding, and this is where it all becomes a real problem. Because in a real job, when something breaks at 2 a.m., you can't wait for AI to debug it for you if you don't understand the system. So when a senior engineer asks you to explain your approach, you need an answer. When the requirements change and the whole feature needs to shift, you need to know what to touch and what not to touch. If you can generate code but can't explain it, test it, or fix it, you haven't become a developer. You've just became dependent on a tool. That's the difference between using AI as a tool and hiding behind it. Think about a carpenter. A carpenter who uses a nail gun is still a carpenter. They know what you're building. They know why each piece fits where it does. They know what a good joint looks looks like. Someone who just picks up a nail gun with no idea what they're making. That's not a carpenter. That's someone just holding a dangerous tool. Using AI is not the problem. Using AI without building the core understanding of the fundamentals is the problem. Here's something I want you to think about. AI generated code can be wrong, right? Quietly wrong. They sound very confident, but they can be wrong. It can be logically broken. It can be insecure. It can work fine for simple cases and completely fail the moment a real user does something unpredictable, which happens all the time. It can solve the problem, but in a way that makes a code base a nightmare to maintain later. There's actually research showing that developers who use AI tools heavily still don't fully trust the output. They use the tools, but they check the output. They test it. They have to look for what's broken because the code that's coming out faster doesn't mean the code is coming out right. Here's what matters for you as a student. When output becomes easier to produce, judgment becomes the valuable. Knowing how to test code properly, knowing how to read through logic and catch what's wrong, knowing how to think about edge cases, knowing when something looks right isn't actually right, that skill is becoming more important, not less. Because now there's more code than ever in the world, more code being generated faster, and someone still needs to decide what's good and what's not, and that someone needs to be you. So let me just bring this together. The engineer who succeeds in this next phase is not just a coder. You're not the person who knows the most syntax. You're not the person who's fastest at prompting AI. The engineer who succeeds is what I would call an AI native builder. Someone who can hear a real problem and break it down into smaller pieces. Someone who can use AI to move faster without you losing the ability to understand what's happening. Someone who can review the output, test it, and fix what's wrong. Someone who can understand why a project is being built, not just how. Someone who can take a project from idea to something that actually works. This is not some rare superhuman thing, but it is definitely a different set of skills than just prompting AI, or a different set of skills from just knowing the syntax. Look, you need to hear this. AI doesn't make you useless. AI gives you leverage. If you have the understanding, AI helps you build so much faster, test faster, ship more, do more, and you become the person who can do in 1 week what others take a month. But that leverage only works if you have the foundations as a proper software engineer. If you don't have the foundations, AI just outputs a lot of confusion a lot faster. Okay, so let's talk about the practical part. What should you actually be doing right now? So one, learn the fundamentals. Do not memorize your syntax. You don't have to do it anymore, but you need to know how to read it. Because if you can't read the code, you can't review AI output. You can't debug it. You can't tell what's wrong. The fundamentals give you the ability to judge whether the AI code is right. Two, practice breaking problems down. Take any problem and ask, what are the smaller pieces? This thinking skill is fundamentally the core of software engineering, not the language, not the framework, but the thinking and the problem solving. Three, learn how to debug tests. I know it's not glamorous. I know most students rush past it because they don't like this topic, but this is one of the most valuable things that you can build right now. Knowing how to find what's wrong, knowing how to prove something works, this matters more than ever today. Four, start thinking about products, not just code. Why does this feature exist? Who uses it? What does the correct outcome actually look like? Start asking these questions even in the smaller projects. Five, build real things, not just tutorials. Build something that solves an actual problem, break it yourself, fix it, deploy it, explain it to someone else what you built and why you built it, and try and get some users on it. So let me just close with this. Will AI replace software developers? Honestly, AI is already replacing a version of software engineering, the version where knowing syntax is just enough, the version where copying patterns from tutorials and building basic RUD applications was the whole job. That version is gone. It's never coming back. The future of software engineering is not smaller, it's way bigger. It's higher level. Engineers who will thrive are the ones who understand real problems, can guide AI properly, who can test and debug and ship things that work, and who can understand what they're building and why it matters. Those engineers will not be replaced. They'll be more valuable than ever. So don't become the person who just relies blindly on AI code. Become the person who knows what to build, why it matters, how it should work, and how to prove it works. That's who's ready for what's going to come next.